Alrighty friends, hi. Today we are going to do lesson 7.11. This lesson is about the order of operations, which is something we haven't really learned yet. So I want you to flip open to page 427 so that you are on the page and we can work this together. So today's lesson is sort of an investigation. We're going to figure out why we need an order of operations. I know that the word order means that I do some things before others, and operations are things like addition, division, multiplication, and subtraction. So why do you think that we would need an order of things? Let's look at this question right here. You can use what you know about acting out a two-step word problem to write one equation to describe and solve a two-step problem. So what that means is that we can have one equation with two steps and just solve that. So if you solved a two-step problem, that means you had to do one operation and then another in a different order. What do you think might happen? For example, if my equation was 4 plus 16 divided by 2, what would happen if I solved it by doing addition first and you solved it by doing division first? I just want you to write what you think might happen on this line. So take a second and write down what you think would happen. What would happen if you solved a two-step word problem in a different order than one of your friends? All right, so now that you've written down your answer, I'm not going to write anything down because I want you to focus on what you think would happen. Make sure your answer is written down, and I want you to hold on to that thought, and then we'll talk about it. So it says, use different orders to find 4 plus 16 divided by 2. Make a list of all the possible orders that you can use to find the answer to 4 plus 16 divided by 2. Well, one order I could do is that I could do addition first, addition, then division. So I could do that. That's how it's listed, right? Addition first, division second. Or I could swap the orders and I could do division first, then addition. If you run out of room, that's okay. Just write off to the side like I did. Now it says use each order in your list to find the answer. So let's try and solve these problems. I'm going to solve it in this extra space over here so that I have a little more room. So I'm going to start the way it's listed. Let's write 4 plus 16 divided by 2. That's how it's listed. So I'm going to do the addition first. Let's do this 4 plus 16. If I do 4 plus 16, I know I can use the commutative property and just do 16 plus 4. So let's count that out. 16, 17, 18, 19, 20. So 4 plus 16 is going to give me 20, and then I'm going to divide it into 2. So then I got to do 20 divided by 2. And I know that dividing by 2 is like chopping something in half. So if I put 20 counters into 2 groups, let's see how many would be in each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So let's see how many are in each group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So make sure you're solving this along with me, right? You should be doing the work as I do it. So 20 divided by 2 would give me the answer of 10. So if I solve it this way, I would get the answer 10. So I'm just going to circle that just so I know. Now let's flip it and solve it the other way. So we're going to use the lines this time. We could do 16 divided by 2 first, and then we could add 4. So let's try doing it by this way. So 16 divided by 2 is what I would do first. Well, I just divided 20 into 2, and now, instead of drawing this one, I'm going to think, what two numbers can I add together to make 16? Because I know that it's going to be the same number and the same number twice. So I know that 8 plus 8 is 16, which means that 16 divided by 2 is going to give me 8. And then I still have to add 4. And 8 plus 4, let's think about that. 8, 9, 10, 11, 12. So 8 plus 4 is 12. And I'm going to circle that now. So we just did 2 different orders, and we got 2 different answers. So let's draw some conclusions. Did following different orders change the answer? Yes, it did, because we got 10 one time, and we got 12 another time. If a problem has more than one type of operation, how does the order in which you perform the operations affect the answer? Well, I want you to think about that a moment. If a problem has more than one operation, how does the order in which you perform the operations affect the answer? Well, we know that it affects the answer because we do one step first. So if we were to do division first here, or we did addition first here, we had a bigger number to divide by. When we did division first here, we had a smaller number to add. So if a problem has more than one type of operation, the order affects the answer because it determines what we do first. So we don't have a lot of space here, so I'm not going to write a complete sentence, but the order in which you perform the operation affects the answer because it determines what you do first. Now the last question says, explain the need. That means explain why we need to set an order of operations that everybody follows. Well, we need to all follow the same order of operations so that we all get the same answer. So I'm going to write, if we didn't follow the same order, we would all get different answers. All right? So take a second to make sure you have that written down. Your spelling does not have to be perfect. We just want it down on paper. Now I want you to flip the page, and we're going to go to page 428 and look at the order of operations really quick. So we're going to make some connections. When solving problems with more than one type of operation, you need to know which operation to do first. A special set of rules called the order of operations, that's important for me to remember, gives the order in which calculations are done in a problem. So what you do first is you multiply and divide from left to right. So that means if multiplication and division are both in the problem, you're going to do whatever is on the left first. So we always, I'm going to box this, you always multiply and divide first. Then, so after you get all the multiplication and division done, then you add and subtract also from left to right. So let's look at an example here. Megan buys 2 books for $4 each. She pays with a $10 bill. How much money does she have left? So we could write this problem out using this equation. $10 minus 2 times $4 is going to give us some answer. All right, so let's use the order of operations. I'm going to write it without the money signs just so you can see it a little bit better. 10 minus 2 times 4. Well, step 1, that's this right here, we multiply and divide. So I'm going to do the multiplication first. I'm going to put a little bracket around there to help me because we multiply from left to right first. So when we do that, we get 2 times 4, which is going to give us the number 8. And so they wrote in the number 8 there for you. Now, to finish, we then subtract because subtraction comes after. So we subtract from left to right, which means we do 10 minus 8, which would give us 2. So how much does Megan have left? She has $2 left. And then we got to figure out, does our answer make sense? So Megan buys 2 books for $4 each. She paid with a $10 bill. How much money did she have left? Well, 2 books for $4 each, 2 times 4 would give us $8. If we paid with a $10 bill and it was worth $8, does it make sense that we would only have $2? Yes. $2 left? Yes. So I'm going to write, does our answer make sense? Yes, comma, it makes sense because the books cost $8 total, and she used $10. So notice when I need to explain my answer, I'm going to explain exactly why it makes sense. So I'm not just going to say yes because I checked my answer. I'm going to say yes because we did multiplication here to double check it. All right? So now you're going to go on to the class kick and you're going to solve these problems down here.